Hello all. The previous class we have seen data types in Java, right? Primitive data types. So we have byte, short, int, long, and float, double, cat, and boolean. So these are the primitive data types we have. So yesterday we have also seen the default value of these primitive data types, right? So and also there is one more thing we have. So when you declare a long value, so if I create a long variable, L equals to 100. See, you make this as a long, just append with a L, small l or capital L. Okay. And if you want to define a float, so float f equals to 20 dot suffix with f. Okay, suffix with f. Float f equals to 20.5. So you may have a doubt, right? So this 20 is double or float. So this 20.5 is double or float. By default, the value is double. Any decimal, by default, the value is double. And if you make it as a float, you just put suffix like this is. And this 20, is this double or long or short? So by default, this 20 is int. Okay. If you are not mentioned, so this L, whenever you declare long, when it take default as int. Okay. Short S and long L. See, generally we use for long, okay, put L, a small L or capital L, okay, or a float, okay. So by, if it is a float, you can use F. If it is a long, you can use L, small l or capital L. No. So these are the data types we have and those memory sizes. Okay. And so this is the concepts we are completed yesterday class, right? And do remember, see, Java is 100% object, right? But here you are using primitive. So see, Java is 100% object, right? But here you are using primitives. There are primitives data types only, right? Then why do you not say Java is 100% object? And if you say each and every primitive is having its equivalent class type, okay? If I say this primitive type, it has having the own class types. Got it? So ఈ ప్రిమిటివ్ టైప్ ఏదైతే ఉందో దీనికి దేర్ ఈజ్ ఏ క్లాస్ టైప్ అన్నమాట. సో ఈక్వివాలెంట్ క్లాస్ టైప్. ఓకే. సో జావా ఈజ్ 100% ఆబ్జెక్ట్ ఓరియంటెడ్ ప్రోగ్రామింగ్. Object oriented programming. Okay, I just telling the theory, guys. So still Java supports primitives. Okay, still Java supports primitive to use. Each primitive data type in Java is having its own reference types. Okay, so in Java is having its own reference type, each primitive data type. Okay, those reference types we can call it as wrapper classes. So those, so wrapper classes, wrapper classes. Okay. So each primitive data type is having its corresponding reference data type. In those reference data types, we can call it as wrapper classes. Okay. So we can call it as wrapper classes. And so wrapper classes are used to wrap those primitive types into an object. So which provides a way to use primitive as an object when needed. Okay. Okay. Now we'll see those wrapper classes. Okay. Okay. Now we'll go to write wrapper classes in Java. Okay. So we have a primitive data types, right? So let me quickly take those. So yesterday we have take this, right? So primitive data types. So let me take these same data types into so these wrapper classes. So let me delete this. So delete this. So enter. Okay. And long and height float decimal and okay. Okay. So these are the primitive data types we have. So each primitive data type, it has own corresponding wrapper classes. So those wrapper classes we can call it as non-primitive or reference type or class types. Okay. We can say non-primitive or reference data types we can say. Okay. Those wrapper classes. Okay. So these many names we can call it as these wrapper classes. So reference data types, reference data types. Okay. So, so these many reference type. So let me quickly write those. For byte, for byte, be capital here, byte. For short, short. Okay. For int, integer, integer. For long, long. For float, F capital, float. Double and for character and boolean, boolean. So these are the Vapor classes we have. Okay. So these are the vapor classes we have. So for byte, byte. For short, short. So these right things are capital. See, these are the primitive types we have. These are the non-primitive or reference data type. We can call it as class types and we can call it vapor classes. So the key features of vapor classes, like there are some features of vapor classes. So these vapor classes allow primitive to be yeah, treated as objects. Okay, these classes allows primitive to be treated as objects. This is useful because many data structures like collections in Java, right? So we have a collections in Java, so can only store objects, not primitive data types. So collections framework law, you can't store these by these primitive data types. Only we can use these objects. So if I say these class types means we can create objects, right? So simply we can create object for this particular byte on short, integer, and long, float, double, character, boolean. So in collections only stores objects, not primitive type. Okay, like the object represents and utility methods. Okay, those vapor clauses provide utilities methods for converting between um, types, parsing, strings, and more. Okay, so there is a conversion techniques we have, parsing techniques and all. For example, int. So integer object class have methods like parsing like that. I'll show you how to convert these things also. Okay, a string to an int. So string నుంచి మనం int కి కూడా కన్వర్ట్ చేయొచ్చు. ఓకే, and and strings and string immutable. So instead of vapor classes are mutable. So once a vapor object is created, its value cannot be changed. Okay, vapor class అనేది change అవ్వదు, it's immutable. Okay, so for example, let me take one. See, as of now, you know, right? This is, and so by default, there is a package we have, Java lang package. These are available, java.lang package. Okay, where these wrapper classes are stored. Package means it's nothing but a folder. Okay, the default folder we have in whenever you install your Java and all. So those. Okay, package. So now let me go to section here. Let me say, so if I say integer, I'll create object, right? Just now I said, right? So let me create integer object here. Integer I equals to new integer. Okay. So within this, I am giving 100. Okay. The object of integer is taking 100. So it is taking 100. Now let me print this. Let me print this. System dot out dot println and with semicolon that I printed. So integer class object I created here. Let me define it. Integer class object is created. So then it is taking value of 100. Okay. So let me try to print this. So how to print? So okay. So Java C test. See what happens. Test Java. You okay? So warning. See, that is just warning. Integer class object announce. Okay, matters for removal. So warning, that is just warning. 100 is returning. Okay. So compilation success. That is just warning. Okay. An integer has been deprecated and marked for removal. Oh, no need. Okay. 100 is returning. Okay. Now let me go back to this here. So this is integer, right? Refers I reference integer. Okay. Let me give 120 this time. And again, save. Okay. So 120 is printed successfully. Now I am taking, I'm taking 100 only here. Now int a equals to 120 and let me print this int. Okay, let me print this a. So now a. Okay, so now Java C. Okay, that is warning only. No need to do anything. So 100, 120 is printed successfully. Okay, so 100, 120 is printed successfully. Now let me define it. So let me define system.println. So I value is, let me concat it. Okay, now same a value is, oh, oh, let me try to run again. Okay, so I value is 100, a value is 120 is printed successfully. Now, okay, now we'll do one thing here. So here, so see here, if I remove this, we'll see the error here. See, no stable constructor found for integer, no arguments. Means integer I equals to new integer. So is not applicable. So arguments listed difference in length. So actual and formal. There is no length of this. So it is taking some arguments within the constructor. Okay. So now let me keep with this 100. Okay. Now save it and run it. Okay. Just those are okay. Warning messages only. Oh. So now we'll do one thing. Okay. We'll do one thing. Let me take one more integer object here. Okay. Here. I'm taking one more integer object here. So this is I2. Let me define I2. So instead of giving 100 here, I am providing A. Okay. And let me print system dot out dot println I2. I2. Save. Oh. Now let me try to clear this all. Okay. Okay, Java C. Okay, those are two warnings because we are running in CMD, right? That's why there is a warnings. Okay, the version and all like that. So see, I value is 100, A value is 120, and this is I2 value, right? So let me define I2 value is, and let me remove this. No need, right? We can remove this. Just I am, so I take one int A equals to 120 and I am printing that A value. And again, I am taking integer object I created. Within the integer object, I am passing this into A value. Okay. Now I am printing this. So now I am printing this. What happens? We'll see. Okay. So A value is 120, I2 value is 120. So that means, so what we do, so this conversion of primitive type data type into a wrapper class object. This called boxing. So this conversion process, we can call it as boxing. Means a primitive. See, this is int a equals to 120 is a primitive data type, right? So then we assign this a value into a integer. That means wrapper class. So wrapper class object. Now, this conversion process, we can call it as boxing. Okay? Boxing means I2 ref I2 I is a reference type I2. Okay? This is called boxing. Boxing. This technique we can call it as boxing. So your primitive type is converted to a wrapper class object. Right? Yes, sir. Now, okay. Now, see, this integer is a predefined method of predefined class of your Java is providing for you. Okay. So when I say in Java, if it is starts with capital letter, we can create a objects, right? If it is a class, we can create object. Okay. See, if your test class is a class, right? We can create a object. Same also, these are the predefined classes we have. Okay. Next. So next, um, let me do one thing here. Okay. So this type of technique is boxing, right? Now, now let me take one more integer I have. So let me take one more integer I have. So within this, I am passing 100 value. So this is I only. So there is no I variable we declare, right? Now integer I equals to new integer. And now int b equals to I dot I dot int value. Int value. Okay. Int b equals to I dot int value. Okay. I am referring this I here. See. So this int value method. So this method extracts the primitive int value from the integer object. In this case, it converts the integer object with the value of 100 back to a primitive int and assigning it to the variable A. Sorry, variable B here. Okay. Now let me take one system dot out dot println ends with semicolon, none B. So this is B value, right? So B value is, so B. So here, this technique we can call it as unboxing. Okay, unboxing. So converting a vapor class object to back to into a primitive type of, okay, primitive type. Okay, see here, vapor class. This integer is a vapor class. Now this is a primitive type, right? Int b, and by using int value method. Okay, int value method. This method will take int primitive type. Okay, now let me try to run this. This is unboxing. This process of technique is unboxing. 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 Okay. So two warnings. See, B value is 100. Okay. This is, so first one is primitive type to reference type, vapor type object we convert, and vapor type to primitive type unboxing. So that's it. So that's it I have guys today. Okay. Bye bye. Please subscribe my channel.